So this means that the cat has a 50% chance of being alive or dead. If you take a light source that emits one wavelength, like a laser, and shine it through two slits cut out from a piece of card, the laser will form a pattern on the surface behind the card. This pattern is caused by the interference of light waves that travel from each slit. The bright sections are caused by constructive interference, and the dark sections are caused by destructive interference. If this experiment is done using particles instead of waves, then only two strands will appear on the surface behind the card. This is because a particle can only go through one slit at a time, and can't interfere with itself, meaning it only lands in one spot. But what do both of these experiments have to do with quantum mechanics? Well, if we do the same experiment, but this time we use electrons instead of light waves or particles, then something unusual happens. The electrons form the same pattern that the light waves formed, despite electrons being particles. It would make more sense for the electrons to have formed two strands instead of the multiple strands, so something else is going on. It might be that when the electrons are fired through the slits, they bounce off each other in mid-air and form the pattern of multiple strands. So if we fired the electrons one at a time, they wouldn't have anything to bounce off and should form two strands. However, this doesn't happen. Even when the electrons are fired one at a time, they still form the multiple strand pattern. Now this is where it gets even more unusual. If you place an electron detector in front of one of the slits to detect when an electron travelled through that slit, and then start firing electrons, they will form two strands on the surface behind the cards. How is it possible for an electron to act like a wave when unobserved, but then act like a particle when it is observed? Well, as it turns out, electrons might not really be particles. Electrons are not just particles. Very small particles can be expressed as a wave function, which describes their position and state. This function shows us the probabilities of a particle existing in certain positions, meaning that an electron can exist in any number of positions in the universe, until it is observed as being in one position. This is what allows the two patterns shown in the electron double-slit experiment to occur. When not being observed, an electron will exist in multiple possible states, allowing it to travel through both slits at the same time, interfere with itself like a wave, and form an interference pattern on the wall. When it is observed travelling through one slit, it cannot exist in two positions at once, which means that it acts like a particle and forms the two-strand pattern. There's a lot more that I could talk about with quantum mechanics, but I think if I went on for too long, I'd probably get something wrong. And I probably have got something wrong already, so for now, I'll link in the description some of the videos I used for research, so go watch them and understand quantum physics better than I probably have. But that's it from me, so I'll see you in the next video.